Step outside on a cold morning. Watch a horror movie alone at night. Or just listen to the one song that always gets you, right at the exact same second, every single time. Three completely different things. Nothing about them should have anything in common. And yet your skin reacts to all three exactly the same way. Tiny bumps, hair standing up. A reflex so old, so automatic, that you've never once had to think about triggering it. You just don't know why it's still there.
Here's what's actually happening. Attached to every single hair on your body is a tiny muscle, smaller than a grain of rice, called the erector pili. When it contracts, it pulls that hair upright. Multiply that by the millions of hairs covering your skin, and you get the bumps. That muscle wasn't built for you. It was built for an ancestor covered in thick fur.
In animals with real fur, that same muscle does two jobs. First, it traps a thicker layer of air against the skin when the hair stands up. Insulation, on demand, in seconds, whenever the body senses cold. Second, in moments of fear, it makes the animal's coat puff outward, making it look larger and more threatening to a predator or a rival. A cat's back arching, its fur standing on end. Same muscle, same reflex, just with enough fur left to actually see it working.
Charles Darwin noticed this pattern back in 1872 in his book on the expression of emotions. He described the exact same skin reaction in humans that he'd observed in startled or cold animals. And he was already asking, over 150 years ago, why humans still had it. We'd lost the fur. Nobody had lost the reflex.
Quiet, quiet. For a long time, that was the whole story. Leftover reflex, no fur to act on, harmless quirk. Case closed. Then, in 2020, a research team at Harvard, led by stem cell biologist Ya-Che Shu, published something that complicated the whole picture. Studying mice, they found that the erector pili muscle isn't just sitting there doing nothing between Goosebump episodes. It's physically connected to the stem cells at the base of the hair follicle, the cells responsible for growing new hair.
When the muscle contracts repeatedly over time, it doesn't just pull the hair upright. It appears to signal those stem cells directly, nudging them toward activity. In the study, more frequent activation of the muscle was linked to increased hair growth, in mice at least. Whether the exact same signaling holds true in human skin is still being studied. In other words, this useless leftover might be doing something after all, just not the thing it was originally built for. Not insulation, not intimidation. A completely different function, quietly running through the same old hardware, discovered less than 5 years ago.
Nobody designed it to do this. Evolution didn't plan ahead for stem cell signaling in a species that would eventually lose its fur entirely. It's an accident of biology, old wiring, repurposed by circumstance, still doing something, even if it's not the something it was built for.
But none of that explains the strangest part of this reflex. Why does the exact same muscle fire for fear and for music? Those aren't even remotely the same experience. Fear makes sense mechanically. The erector pili muscle is controlled by the sympathetic nervous system, the same system responsible for your fight or flight response. Cold, danger, a sudden scare, all of it runs through the same nervous system pathway that triggers the muscle. That part is well understood.
Music is where it gets complicated. Neuroscientists studying this phenomenon, often called skin orgasm, or more formally, frisson, have found that it tends to happen at moments of musical surprise, an unexpected key change, a sudden swell in volume, a voice hitting a note you didn't expect. Brain imaging during these moments shows activity in regions associated with reward and emotional processing, some of the same circuitry involved in pleasure and anticipation. Neuroscientist Robert Zatorre at McGill University has spent years studying this exact phenomenon. His research found that musical frisson triggers a measurable release of dopamine, the same neurotransmitter involved in food, sex, and other survival-critical rewards. Your brain in that moment is treating a chord change with roughly the same chemical seriousness it would treat something your ancestors needed to survive. So the leading theory is this: Goosebumps aren't really about fear or cold or music specifically. They're what happens when your sympathetic nervous system gets triggered by something emotionally intense enough, and it doesn't appear to care much whether that intensity comes from a threat or from beauty. The body seems to run one reflex for two very different reasons, without much of a filter in between. Not every researcher agrees on why intensity alone would be enough to explain it. It's a leading theory, not a settled one. It's not malfunctioning.
It's not confused exactly, it's just old. Old enough that fear and beauty still run through the exact same wire. Because nothing ever came along to build a second one. Every time your arms prickle during a chorus or a chase scene, or the moment right before something scary happens in a dark room, that's not a new feeling. That's one of the oldest reflexes your body has, still firing for reasons that have almost nothing to do with what it was originally built for. So the next time it happens, cold morning, dark room, that one song, you'll probably still just rub your arms and keep moving. You won't think about the muscle. You won't think about the fur you don't have anymore, or the fact that evolution never quite got around to giving fear and beauty separate wiring. The reflex doesn't need you to notice it to keep working. It never has. It's been firing the same way for longer than there's been a you to feel it happen.
Maybe that's the part worth sitting with. Not the goosebumps themselves, you'll forget about those in a few seconds, like you always do. But the fact that some tiny, forgotten piece of your own biology is still standing guard for a threat that stopped mattering a very long time ago, with no idea it's allowed to stop. It doesn't know the difference between the two things that scare you and the two things that move you. Maybe in the end, neither do you. Not really. Maybe that's exactly why both feel like something.